fifth part of the session, where I will be telling you how to provision the AWS resources using Terraform and GitHub Action. So we have already seen the Terraform files in the previous session. So now we will be deploying the resources in the AWS account using the GitHub Actions. So let's go directly to the pipeline and see it's step by step. So this Terraform.yaml file we have already seen. We have seen that we have added two jobs previously in the session, which was tflin checks and the tfsec checks. So these two tools were basically checking the syntax as well as the security checks in the Terraform file before it is deploying the Terraform files. So now we have added additional two more jobs. First one is Terraform setup and the second one is install services. So in the Terraform setup, what is happening is like we are giving permissions in this job of ID token write and contents read. So ID token write is equal to means it is used for a job to connect to the identity token to receive the token, while contents read means we have read access to the repository. This job is having the read access to the repository. Then it is running on Ubuntu latest machine, this job, and needs this name means this job will only run if the previous job is finished. So it is running sequentially. So if the previous job has run successfully, then only this job will run. So that's why this needs parameter is added. Then let's check step by step the different steps that we have added in this job. So the first step is first we are checking out the GitHub repository, and in the second step we are authenticating the GitHub actions to AWS using OIDC roles that we have discussed in the previous session, using the role that we have created earlier, and this is the session name. And we have also added our region, which is US East 1. In the next step, what we are doing is we are installing Terraform by these commands and checking the Terraform version, and then we are doing Terraform init and validate here. We are going to the Terraform code where our main.file and backend.ts files are present, where actual modules are present and collaborating all the resources. Then we are doing Terraform init, initializing all the modules and all those things and libraries, while Terraform validate is validating all the validating if all the syntax is correct or not. Then the next step is to create a plan of what changes is made and run the plan with the command Terraform plan. The step is followed by a check to see if a plan was successful or not. Here you can see by using an if-else. So here it is telling that by the output whatever it is present, we are checking whether it is fail or not. If fail, then we are exiting from in the pipeline, and it will exit directly, and if not, then the pipeline will continue. Same applies with the apply also. So it is also applying. Well, if everything is fine with the plan, then it is getting applied, and we are doing auto approve. So this is also by a check to see. This is also there is also a check here to rectify whether there is some issue with the Terraform apply or not. So if there is no failure, then it will pass the next step. It will go to the next job. Otherwise, it will exit the pipeline here. So then comes the fourth job, which is install services. So there are many things that we need to install, and we will discuss more about these. So the scripts that we are installing in the next sessions. So now we will just go through the pipeline and get a background of it, what we are doing. Then again we are giving permissions of write and read here for the OIDC token that we have created and the content. Then we are again running this in a separate Ubuntu latest machine. Then this job is also running sequentially. Like it will only run if the previous job, which is Terraform setup job, is run successfully, has run successfully. Then, and this job has an n number of steps that it is running. Again, it is checking out the repository. It is connecting to the AWS using YDC. Then what we are doing is like we are getting the public IP of the GitHub hosted runner. Like this GitHub runner, which where the our job is running, should have a public IP, right? So by this action, public IP 1.3, we are getting the public IP of this GitHub Actions Ubuntu machine. Then what we are doing is like we are getting the security group of the EC2 instance that we have created. Okay, whatever the EC2 instance that we have created by Terraform, we are adding the we are getting the security group. So how we are getting the security group is by using the CLI command. So here you can see that we have passed this EC2 name. So this EC2 name is coming from here, which here we have present the EC2 security group name. We are simply giving the security name that we have present, that we have added in our Terraform file. By this way, we are getting our security group of the EC2 instance that we have created. Like this is the secure. There are certain resources that that is created by Terraform. First is this EC2 instance. Then this is the role that is created. So this role is attached to this IAM1. Then this is the ECR Spring Boot app, where we will be pushing all our images. And this is the S3 bucket where our backend is present. You can even see here that there is a Terraform file which has got created, and this is the state file basically. So this is the state file which has got created here. So here you can see the whole state file, that what all things has been created here by Terraform. So let's move into the pipeline. So basically these are we define secrets by using this syntax. It is secrets dot the variable name. So we are passing all the secrets here. I will show you all the secrets. So all the secrets are present in the settings of the GitHub repository. So here we are just passing the security group name of the EC2 instance, and it is giving us the security group ID of the EC2 instance. Okay. Then what it is doing, by using this CLI command, we are passing the the IP address, whatever we have got of that GitHub hosted runner, which is the Ubuntu machine of this GitHub. That Ubuntu machine IP we are whitelisting into the EC2 instance, so that this GitHub Actions runner, that Ubuntu runner that we have defined here, can access our EC2 instance. So that's why we have added this part. So here what we are doing is like we are giving 22 port access here. Then what we are doing is getting the public IP of the EC2 instance. So the public IP we are getting by using the EC2 instance name. Then after this step, getting the public IP of the EC2 instance, what we are doing is like we are setting this output. Like this is the syntax for setting our output, so that we can use this output. Like the output variable name is ec2.ip to any of the other steps. In the same job, any other step we can use this. So here you can see. Then we are copying script files via SSH. Via SSH. So if I open here and show you the scripts, so these are certain scripts that we are installing into the EC2 instance. So first what we are doing is we are copying the whole script, like each of these scripts into the EC2 machine, to the new EC2 machine that we have created using Terraform, and this is the host name of the Terraform. The public IP of the Terraform we have got from here, from this step. Then we have used username, key, and this is the source part, which it is a path where in the GitHub file our scripts are present, and this is a target, like where we want to paste the scripts files into the target machine, like the EC2 instance which we have just created. Then what we are doing is, like, by using SSH, that this Ubuntu machine, runner machine in this job, it is SSHing into the EC2 instance, and then what it is doing, it is running whole of the batch script. First it is doing ch mode so that it can execute each and every sh command, and then it is running each and every .sh command. So the first sh command is to install Docker, then Sonar Cube, then it is installing kubectl, then it is installing Minikube, then Trivi and Terrascan. So we will discuss these scripts later in the session. And then after everything is installed, it is removing the scripts from the EC2 machine that we have created. Then it is also removing the GitHub Actions Ubuntu machine IP address from the EC2 instance security group, so that it doesn't increase the limit every time the Ubuntu machine's IP address changes, right? So we have to make sure that we don't fill up the limit of that IP address. We need to remove the previous one, so that next time whenever the pipeline again runs, then the new IP should be added into the EC2 instance. And at the last, what is happening is that this is the trigger. So we have added this trigger next to for Ubuntu. This we have added so that the next workflow, which is Spring Boot application workflow, it runs like basically we do sequential workflow trigger. The other workflow can trigger only if this thing is passed. So here it is using Peter Van Span. We are giving an event type, and it is telling that whenever this whole workflow is finished, then only that another workflow, which is Spring Boot workflow, should run. So this is the whole pipeline. Thank you everyone. This is all for the first part of the session. Thank you.